This is note 6.2, different forms of linear equations, day 1. We have 3 different types of linear equations. The first one is called standard form. Standard form is ax plus by equals c, where a, b, and c are just numbers. There's a few rules for standard form. The first is that the numbers a, b, and c have to be integers. In other words, they must be whole numbers. If there's a fraction, to get rid of it, we can multiply by the denominator. The second rule is that the first number, a, has to be positive. If it's negative, then we can divide everything by -1 in order to make it positive. Most of the time, standard form is used for word problems. The second form of a line is one we're very familiar with. It's called slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept. When we are trying to get lines into slope-intercept form, we are always going to solve for y, or get the y by itself. The third form of a line is called point-slope form. In point-slope form, we have a point, y1 and x1, and we have slope, m. So point-slope form is y minus y1 equals m times x minus x1. And we said that m is slope, x1 and y1 is any point on the line. Notice that since in our equation we have minus, that means that when we put it into the ordered pair, we're going to use the opposite sign. Our first 2 problems say, convert each equation from slope-intercept form into standard form. Standard form is ax plus by equals c. Remember, for standard form, we cannot have any fractions. So for number 1, y equals -1/2 x minus 7. First, I want to clear the fraction. Get rid of that fraction. And I can do that by multiplying by the denominator, or the bottom number. In this case, it's 2. So when I multiply by 2, in an equation, if we do it to one thing, we have to do it to everything. So I'm multiplying everything by 2. I get 2y is equal to -1/2 times 2 is -1. We did that so that we get rid of the denominator, get rid of the fraction. X, -7 times 2 is -14. Our second step is we want to move that -1x. We can move -1x to the other side by adding 2y and 1x are not like terms. So I'm left with 1x, because I want to have the x first in my equation, plus 2y equals -14. Remember, I don't really need that 1 in front of the x. I never need a coefficient of 1. So a better way to write this is x plus 2y is equal to -14. This is in standard form. The x is first, then the y, and then an integer on the other side of the equal sign. All of my coefficients are integers. They're all whole numbers. And the a value, or the number in front of x, is positive. So this is correctly in standard form. On number 2, I have y equals 2x minus 7. I don't have a fraction this time, so I'm going to start by moving 2x to the other side. It's positive, so I can move it by subtracting -2x and -2x. Since standard form is ax plus by equals c, I want the part with x to come first. Since I'm subtracting, that negative stays with the 2x. -2x, positive y, is equal to -7. All my coefficients are whole numbers. However, remember we said that a, or the number in front of x, has to be positive. So in order to get rid of that, I'm going to divide everything by -1. -2 divided by -1 leaves me with positive 2x. There's really a 1 in front of this y, so positive 1 divided by -1 is -1y. And -7 divided by -1 is positive 7. Remember, I don't really need a coefficient of 1, so I can write this better by writing 2x minus y is equal to 7. All my coefficients are whole numbers, and my leading coefficient in front of the x is positive. So this is in standard form. Our next pair of problems says convert each equation from standard form to slope-intercept form. So we need to convert these into y equals mx plus b. Or in other words, I need to solve for y. On number 3, I'm going to start with boxing the term that I need to solve for. I need to get the y by itself. First, I'm going to move 2x. It's positive, so I can move it by subtracting. On the left side, I'm left with -3y is equal to 9 and 2x are not like terms, and I want the part with x first. So I'm going to have -2x. 9 is positive, so plus 9. We still need to get the y by itself, so our second step is we are going to divide everything by -3 in order to get the y by itself. -2 divided by -3. I want my answer as a fraction. In my calculator, I get positive 2/3, and I keep the x. 9 divided by -3 is -3. So in slope-intercept form, our equation is y equals 2/3x minus 3, where 2/3 is our slope, and -3 is our y-intercept. Okay, same thing on number 4. I'm trying to get it into slope-intercept form, y equals mx plus b. So I'm solving this for y. Trying to get the y by itself, I'm going to start with moving the x term to the other side by subtracting. Minus 4x on both sides. I carry down my positive 5y. 20 minus 4x, those are not like terms. I want the part with x first, so -4x. Positive 20. And to get y by itself, I'm going to divide by that coefficient of 5. I'm left with y equals -4/5 does not simplify, so -4/5 x plus 20 divided by 5 is 4. This is in the form y equals mx plus b, slope-intercept, where my slope is -4/5 and my y-intercept is positive 4. Number 5, convert each equation from point slope into slope-intercept form. So y equals mx plus b. Number 5, I have y minus 5 is equal to 2 times x minus 0. If I'm thinking back to solving equations and don't call me after midnight, I'm going to start with distributing where I see parentheses. Distribute. There we go. Okay. So on number 5, I need to distribute positive 2 to everything inside those parentheses. 2 times x gives me 2x. 2 times 0 is just 0, so I don't need to write that. And I'm carrying down everything on the left side. I'm solving for y, so I'm trying to get y by itself. I'm going to move the minus 5 to the other side by adding. On the left side, I'm left with y. 2x and 5 are not like terms, so I'm just going to write down 2x plus 5. This is now in y equals mx plus b, where my slope is 2 and my y-intercept is 5. On number 6, I have y minus 2 equals 1/2 times x plus 2. I'm doing this the same way. I'm going to distribute 1/2 to everything inside the equation, or inside the parentheses. 1/2 times x gives me 1/2 x. 1/2 times 2 gives me positive 1, and I carry everything down on the left side. I'm trying to get the y by itself, so to get rid of that minus 2, I do the opposite. I add 2 to both sides, and when I add, I'm going to line it up with its like terms. I'm left with y equals 1/2 x. 1 plus 2 is 3, so 1/2 x plus 3. This is in slope-intercept form, where my slope is 1/2 and my y-intercept is 3. Convert each equation to standard form. Okay, so on these I need to get it into ax plus by equals c. Again, I'm going to start with distributing. On the left, I'm going to be left with y minus 2, and I'm distributing negative 4 over 5 to everything inside the parentheses. This gives me negative 4 over 5x minus 12. Remember, in standard form, we have to have whole numbers, so next I'm going to clear the fraction by multiplying by the denominator. Here my denominator is 5, so I'm going to multiply everything by 5. This gives me 5y, 5 times 2 minus 10 equals negative 4x minus 60. Next, I'm going to move my term with x, so I'm moving negative 4x to the other side. It's negative, so I need to add plus 4x plus 4x. It does not have any like terms, so I'm going to have 4x plus 5y minus 10 is equal to negative 60. Lastly, I'm going to move this constant to the other side of the equation. It's negative 10, so I'm going to add 10 to both sides. I'm left with 4x plus 5y, negative 60 plus 10 gives me negative 50. All my numbers are whole numbers, and my a value is positive. This is in standard form. Last one, number 8. I'm following the same procedure. I'm trying to get this into standard form. I'm going to start by distributing. At my parentheses, I'm left with y plus 4 is equal to 2/3 x minus 2. I need to clear the fraction, so I'm multiplying everything by my denominator, multiplying everything by 3. 3y plus 12 is equal to 2x minus 6. I need to have the x be in the very front of the equation, so I'm going to move my x by subtracting 2x on both sides. There are no like terms on the left, so I have negative 2x plus 3y plus 12 is equal to negative 6. I want all my constants, or the things without variables, together. So to move that positive 12, I need to subtract 12 on both sides. I'm left with negative 2x plus 3y equals negative 18. Lastly, one of our rules for standard form was that the first number cannot be negative. So to get rid of that negative, I need to divide everything by negative 1. And this leaves me with positive 2x minus 3y is equal to positive 18. This is in standard form. All my coefficients are whole numbers, and my a value, or the number in front of x, is positive.